Make sure the course server is running and continue with your project from the previous episode or open the starter project for this episode. Build and run the project. Select the file and tap Silver. You've coded the Silver download option, which fetches the complete file in one go and presents an on-screen preview. In this episode, you'll implement the Gold download option, which provides progressive UI updates as you download the file in chunks. You'll do this by reading the file as an asynchronous sequence of bytes from the server. This is similar to what you did in episodes 4 and 5, but now you'll implement some helper methods to work with chunks or batches of bytes. This lets you update the progress bar one chunk at a time as you're receiving the file's contents. In Super Storage Model, locate Download with Progress file. This public method calls the private version of Download with Progress, defined just below. This private method is where you'll add more code. Currently, it defines the endpoint and adds the file name to the publish downloads array. Then it defines a tuple to hold the result of an asynchronous URL session method call. Option-click Async Bytes. This method returns a URL session async bytes sequence, which gives you the bytes it receives from the URL request asynchronously. This closure is empty for now. You don't need it for this episode. Offset is an optional int parameter with default value nil. The Silver download method doesn't set offset, and neither will the Gold method. Only the Cloud 9 plan uses the code in this closure. You'll add this code in episode 16 when you implement the Cloud 9 plan. For Silver and Gold download plans, you just need this standard URL session code similar to what you've already written. You use URL to make a standard request and check for the usual success status code. Option-click Result. A successful response gets you an asynchronous byte sequence stored in result.download stream. Now, above the dummy return statement, create an asynchronous iterator for the sequence. This asynchronous iterator gives you more control over the incoming bytes to update the progress bar. Now Xcode flags an error because the if closure doesn't initialize result. Just comment out the if-else lines for now. You won't update the progress bar after every byte. Instead, you'll process a batch of bytes at a time and update the progress bar after each batch. The starter project includes a custom byte accumulator class. In the project navigator, in the model group, open byteaccumulator.swift. Each chunk or batch of bytes is 20 bytes. Click back to Super Storage Model and Download with Progress to create a byte accumulator and prepare to use it. Stop downloads is a flag you'll set in the next episode. So while the accumulator can still collect more bytes, these two conditions give you the flexibility to run the loop until either the external flag stop downloads is set or the accumulator completes the download. With this design, you're looking ahead to make it easy to cancel the download code by using an external flag. Now add more code inside the while closure. So you put a nested while that runs until this batch is full. The nested while runs until the batch is full or the byte sequence completes. You have to await each byte downloaded and processed by your asynchronous iterator. After a batch completes, it's time to update the download progress bar. Add this line in the outer while closure, but after the inner while loop. Jump down to Update Download to see where this progress value gets used. It updates the current download's progress value. Right-click this progress property, find its call hierarchy. Select downloads.getterBody. This downloads view passes it to progress view. Get back to Superstorage Model Update Download. Remember, Update Download belongs to main actor, so it runs on the main thread, not on whatever threads the iterator and accumulator are running on. This is a safe place to try out task.detached. Apple documentation recommends against using task-detached because it negatively affects the concurrency model's efficiency. But just to see how it works, you'll create the task so it doesn't slow down the ongoing download task. Get back to the last line you added in the download with progress while loop. And wrap it in a detached task. Now that Update Download is inside a closure, you need a self-dot. Download with progress is a task started by a user action, so it runs with user-initiated priority. This detached task doesn't inherit its parent's task storage, execution actor, or priority. Explicitly setting its priority to medium means there's no chance it will slow down the download task. But now that this is a separate task, using accumulator.progress here could cause a data race. So before creating the detached task, capture accumulator.progress in a local constant. Then pass this value to Update Download. Now add a print statement to keep track of downloads during development. And finally, replace the dummy return value. While processing the file in batches of 20 bytes, the accumulator has saved every byte to its data property. When all the bytes have downloaded, you have a file. And now to call your new method. Go to Download View and fill in the Download with Updates action closure. First, copy and paste the download single action code. And change download file to download with progress file. Build and run. Select the file, then tap Gold. Now the progress bar updates a little at a time, and you see the progress printed in the console. You've implemented the progress bar feature of the Gold plan. In the next episode, you'll add more features while learning how to cancel tasks. Make sure the course server is running and continue with your project from the previous episode, or open the starter project for this episode. In this episode, you'll implement the premium download plan, Cloud 9. It downloads files super fast by running 4 concurrent tasks. Each task downloads about 1/4 of the file. You'll start by finishing the private version of Download with Progress in Superstorage Model. Open Superstorage Model and locate the if-let offset code you commented out in episode 13. Offset is nil for the Silver and Gold plans, so you didn't need this if closure. For the Cloud 9 plan, you'll pass in an actual offset value to create 4 tasks. To start, uncomment these lines. In the closure, create a URL request. probably haven't seen this initializer before. Command-click URL request and select Jump to Definition. Select the second option to open utility.swift. This initializer is a custom extension of URL request. The core server you're running supports a capability called partial requests. You can ask for a byte range of the response instead of the entire response at once. You do this by setting the range field in the HTTP header. Here's an example of offset length and range values for a 77,345 byte file broken into 20,000 byte chunks. 3 20,000 byte chunks, and the remaining bytes in the last chunk. When offset is 40,000 and length is 20,000, the range value is bytes equals 40,000-59,999. Don't worry, the starter project code already handles all the calculations to create these chunks. Now click back to Super Storage Model to send the request and store its result. In Episode 5, you used the from URL version of Bytes with a custom live URL session to get a never-ending sequence of stock prices. Here you use the for URL request version of Bytes. You don't need the session to stay open, so shared is fine. This got rid of the error message about uninitialized result. To finish this closure, check the status code almost as usual. Status code 206 indicates a successful partial response. Now jump down to multi-download with progress. This method already includes the code to break a file download into 4 parts. This part info helper function calculates the offset, size, and name values for each part and stores them in the parts array. Jump back to look at the private download with progress signature. Name, size, and offset are precisely the parameters you need to pass to this method. Jump back to multi-download with progress and start replacing this dummy return statement with calls to download with progress. Start with part 0. Define a promise with async let. Then duplicate and edit this line. Next, await an array of these 4 downloads. This executes them concurrently. Now combine their data. The default data initializer gives you the initial value for summing over the array items. And now return the complete file content instead of the dummy placeholder. Finally, you just need to call multi-download with progress in download view. Find the code for download single action and copy-paste edit it into download multiple action. You don't need to store the task in download task. The core server doesn't slow down partial responses, so files download faster than you can move the cursor to cancel now. Build and run. Select the TIFF file and tap Cloud 9. How awesome is that?